Greetings, Suhai Earth Science students. This is Mr. McLeod again. Welcome to our next astronomy podcast. Today we will continue our discussion of the motions of stars, star formations, and planets, and eventually end up showing you how to locate certain constellations in the coming summer sky. I hope you took time to find the Big Dipper. We're going to need it really soon. Honestly, this may be the most useful thing we do in this unit because it's something you can teach others. So get your notes out, something to write with, and let's continue to explore the night sky. Okay, Mercury and Venus are referred to as the inferior planets and are never seen far from the sun. So write that down. Now, these planets appear to move back and forth from one side of the sun to the other, alternately appearing at sunrise, then at sunset. That's extremely important when you want to try and locate these planets, which are very easy to see in our night sky. So write that down. So they move back and forth from one side of the sun to the other, alternately appearing at sunrise, then at sunset. So get that in your notes. Not only are the two inferior planets always found near the sun, but they also exhibit phases. Today we interpret these motions to indicate that the planets are orbiting the sun. Write that down. While we know that ancient astronomers had some less straightforward explanations for that. Now, Mars, Jupiter, and Saturn are referred to as the superior planets. Get that in your notes, just like our lake. The superior planets. You see that here. See those planets here in this picture. Now, the reason we don't include Uranus, Neptune, and Pluto is primarily because they aren't visible to the naked eye. Write that down as well. Now, the superior planets also exhibit retrograde motion, but somewhat differently. These outer planets form loops or S-curves in the sky. Get that in your notes. Now, today, we realize that the retrograde motion of superior planets results from the Earth lapping or passing the planet. Now, rather than before where Venus passed us, we lap the outer planets, Mars, Jupiter, and Saturn, because we travel faster than they do. Get that down in your notes. So the line of sight from the Earth to the planet angles backward against the very distant stars, causing them to appear to move backwards. So make sure you get that explanation in your notes. Just to lock retrograde motion in your mind, let's consider an analogy or example of it. You see here two race cars moving around two concentric circular tracks at the same time. The car that's on the inner track will periodically lap the car on the outer track. Both cars are constantly moving forward, but from the point of view of the inner car, the outer car would appear to be moving backwards. So I'd like you to write that explanation using this analogy in your notes. Okay, let's work on our own night sky now. Not that we weren't before, but now we're going to focus on stars and see if we can make some sense of what's up there. First, and I know you're going to roll your eyes and go, "Oh, you're kidding me." First, draw a picture of this diagram in your notes. I know it's a lot. If you have the space, it may help to hold up a sheet of paper on the screen and trace the stars on it. If not, then do the best you can in your notes because you'll need to refer to this diagram. So get that done right now. Okay, now let's talk about circumpolar constellations. Circumpolar, C-I-R-C-U-M-P-O-L-A-R. Those are star formations we can see all year long. Write that down. Now this diagram shows the major northern hemisphere circumpolar constellations. Let's figure out how to find them. First and best known is Ursa Major. So you see Ursa Major here, of which the Big Dipper is part of it. Ursa Major is actually a big constellation of a bear, is what it is. But you see here that the Big Dipper is part of it, so we just call it the Big Dipper. And we call it part of Ursa Major. Now write that down. That's why it's really important for you to find the Big Dipper in the night sky as soon as you can. Now the reason is because we're going to use it as a focal point to try and find other stars and constellations. Now let's look at the two stars at the end of the bowl of the Big Dipper. These are called the pointer stars. They're right here. Look in here, those are the two pointer stars. If we draw a line through them, they point to Polaris. And we've been talking about Polaris a lot in this class. Polaris is the North Star. So we see this line now that's drawn between the pointer stars, and it points directly to Polaris. So that's how you find Polaris in the night sky. Write that down. Now it's purely coincidence that we live at a time when there's a bright star close to the north celestial pole. Because guess what? There's no South Star. Write that down. Now, since Polaris is the bright star that you see here, you also see that it's the bright star at the end of the handle of Ursa Minor, also called the Little Dipper. Write that down. So we've used so far the Big Dipper to find two really cool things. The North Star, or Polaris, which is at the end of another constellation, Ursa Minor. Now, apart from Polaris and one star in the bowl, Ursa Minor, otherwise known as the Little Dipper, is very inconspicuous, which means it's really hard to see. Write that down. Now the stars in the bowl of the Little Dipper include one from each magnitude, 2nd through 5th, so it's a good guide to estimating star brightness. Also write that in your notes. Now here's a little side note. Most people think they can find the Little Dipper, but what they're doing is mistaking now a star cluster called the Pleiades for the Little Dipper. Get that down in your notes. And you can see the spelling of Pleiades right up here. Now the Pleiades, or 7 sisters, write that down, is actually a cluster of stars, not a constellation. And the Little Dipper is much larger in the sky, and the stars that compose it are faint and difficult to see, especially when there's the least bit of light pollution. So the Pleiades stand out like a sore thumb. You can see them. They're real small. They're about the size of your thumb in the sky. Whereas the Little Dipper is about 5 times that big in the night sky. So people mistake it all the time for the Little Dipper. It's not. You know how to find the Little Dipper now. All right? You know how to find it. Find Polaris. Polaris is the star at the end of its handle. Now the star at the bend of the Big Dipper's handle, right here, the star at the bend of the Big Dipper's handle is called Mizar. Write that down. Now Mizar has a faint companion called Alcor, A-L-C-O-R, not shown here. That's a good test of your eyesight. Write that down. So right next to Mizar, and it's not in this picture, but right next to Mizar is Alcor, A-L-C-O-R. Fairly easy to say, especially with young eyes like yours, with no help from a binoculars or a telescope. Now a line from Mizar through Polaris. So here's Mizar. So a line from Mizar through Polaris finds our next constellation called Cassiopeia. Some people pronounce it as Cassiopeia. Either is fine. So write that down. So a line from Mizar through Polaris finds you Cassiopeia, which is another circumpolar constellation, one we can see all year long. It's got a characteristic W shape, if you see right here, the W-shaped Cassiopeia. It's a remnant of a supernova. Write that down. Remember now, if you can find the Big Dipper in the sky, you can find the rest of these star formations right now in our night sky. They're visible right now in our night sky. Now, two fainter constellations are Cepheus, right here, see Cepheus, and Draco, also known as the dragon. So here's Draco right here. You can see Draco's head right here, and his tail that winds right through the middle of Ursa Major and Ursa Minor. In the movie Dragonheart, the dragon hero Draco sacrifices his life and takes his place among the stars. And the neat thing is that the scene actually shows the constellation accurately. So you're going to have to work on finding these just by location in this map. So you see that line from Mizar through Polaris to Cassiopeia. Just underneath it now is this little Cepheus constellation, and Draco then winds right through the middle of the Big and Little Dipper. Okay, now on to another familiar constellation called the Summer Triangle and the stars that make it up. During the summer month, the Summer Triangle star formation lights the sky from dusk until dawn. Write that down. Now, the Summer Triangle consists of three very bright stars, so let's get them in your notes. The first star is one we mentioned before, Vega, so write that down. Now, Vega is located in the constellation Lyra. So right up here now, at the very top of the triangle, you see the star Vega in the constellation Lyra. We'll talk about Lyra here in a little bit. But the first star in the Summer Triangle is called Vega. Can you remember what's unique about Vega? Recall that right now our north celestial pole points to Polaris, the North Star, but by the year 14,000 it will point to Vega. Can you remember why? If you said because of the precession of the Earth's axis due to the pull of the Earth and the Moon, you get one extra credit point. Now, as dusk deepens into night on a warm June or July night, look eastward for a sparkling blue-white star called Vega. It's very bright. Vega is found at the highest apex. We said that already, right up here. Now, Vega overwhelms as the brightest of the Summer Triangle's three stars, all bright enough to be seen from many polluted cities, light-polluted cities. So again, at nightfall in the summer, look for the brightest star in your eastern sky. You can start seeing it right now. That's Vega, the brightest star in the constellation Lyra. So here we are in Lyra. Now the second star in the Summer Triangle is Deneb. Here's Deneb right down here. Right here. Deneb is in the constellation Cygnus. So write that down. Cygnus is right down here. And we'll talk a little bit more about that here soon as well. To locate it even better, an outstretched hand at arm length approximates the distance from Vega. So an outstretched hand at arm's length distance will find you Deneb from Vega. So write that down. Now, last but not least is a star called Altair. And here's Altair right down here, the last of the summer triangle stars, in the constellation Aquila, which again we'll talk about here in a little bit when we talk about the summer triangle constellations. So write that down. So look to the lower right of Vega to locate the summer triangle's second brightest star. That's Altair, the brightest star in the constellation, the Eagle. So here we are down here, Aquila the Eagle. Now a ruler held at an arm length fills the gap between these two stars. So if you hold a ruler out at arm's length from Deneb, you'll see Altair at that angle right there. Now, as suggested by its name, the summer triangle predominates during the summer season. Even so, the summer triangle can be seen for at least part of the night at any time of the year from our mid-northern latitudes. So a quick review. The summer triangle is made up of 3 bright stars. Vega, up here, Deneb, located here, and Altair, located right here. So it can be seen all summer just east of the Big Dipper in the sky. So write that down. Okay, now let's look at 3 very easy to find constellations inside the summer triangle. We've mentioned them before, but let's look at them in a little more detail now. The first is at the top of the triangle and is called Lyra. Lyra is known as the harp. Write that down. Lyra is known as the harp. Lyra kind of looks like a parallelogram if you trace it here. Kind of looks like a parallelogram. And I guess early astronomers thought it looked like a harp too. If you tip it up a little bit, it looks like a harp. Now, moving clockwise from Lyra, remember Lyra has Vega in it. Moving clockwise now, we find the constellation Aquila, which looks like 2 triangles sort of oddly combined to form the shape. So here's one of the triangles, and here's another right here. Students have also said this reminds them of the shape of a paper airplane or the stealth bomber. Both look pretty good to me, so get either of those in your notes. But Aquila, clockwise from Lyra. Then continuing our clockwise motion around the summer triangle, we run into Cygnus the Swan. Here it is right here. Cygnus has the bright star Deneb in it. Write that down. Now, Cygnus is easily recognizable because the stars in it form what's called the Northern Cross. So here we're going to trace out the Northern Cross. So here's one side of it, and here's the other side of it. So that forms the constellation Cygnus. It's really, really easily seen in the sky right now. So what are you waiting for? Go find them. And now we come to my favorite little constellation called Delphinius. Here's Delphinius down here. Small but mighty. Delphinius is shaped like a kite, complete with a tail. Write that down. Even though it's not inside the summer triangle, the stars in it are bright enough to make it very easy to find in the night sky. It's located just beneath the triangle and is one of the coolest looking constellations, in my opinion. Okay, now back to the Big Dipper. Find that constellation in the sky again. So here's our Big Dipper in the sky. Now, it's a little right or west of the summer triangle. Now we want you to find the handle. So here's the handle of the Big Dipper. See, these stars right here form the handle. There's Mizar right there in the curve. Now, find the handle and follow the curve of the handle south towards a very bright star. I mean very bright. So we follow this arc and we find this star Arcturus. Write this down. In fact, we use the statement follow the arc to Arcturus to find it. So it's really cool. If you just follow that arc of this thing down far enough, you'll find a bright star called Arcturus. The arc being the arc that's the handle of the Big Dipper. So write that down. Another very bright star in the summer sky is Spica. Since we've already followed the arc to Arcturus, so here we are, followed the arc to Arcturus, we now use Arcturus to help us find Spica. Another great way to remember how to find Spica is the statement, drive the spike to Spica. So follow the arc to Arcturus and drive the spike straight down to Spica. Write that down. Spica is the brightest star in the constellation Virgo the Maiden. Also write that down. Here's Virgo. So it's the brightest star in the constellation Virgo. Make sure you get that in your notes. This means that directly below Arcturus is the star Spica. Okay, that completes part 3 of our constellations section of astronomy. Go grab those questions in Moodle, answer them, and submit them when you're done. Talk to you soon. Bye.